Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G and this time we're going to be doing a question for the grade 10s. It's related to wave. So if you struggle with wave, don't leave. Subscribe for the channel and watch the video. Well guys, so we are going to be solving a question on wave. Why on wave? Because it was one of the topics you done at the beginning of the year and then it is going to be very much important for the upcoming examination. This was question 2 done in November 2023 in the Gauteng province. It's a good question, it's a question to refresh, and as usual we're going to go a little bit more than just solving the question. We're going to explain few concepts that maybe you forgot and you need to remember right now. The question says the diagram below represents a transverse wave with a frequency of 1,5 hertz moving from left to right. And there's a picture of the wave. Before we move on, let's find out how many waves are they represented in that specific part of it. So we have from A to this point that represents one wave. All right, second wave will be from there to point C. So up until there are two waves, okay? And then the final one, guys, is going to be from C to just the end of the picture there. That is, so in other words, we have here three waves. In this place here, we have three waves represented. Okay, as you can see in that specific picture there. Now they say define transverse wave, and let's have a look before even answering that question. Let's revise about waves. Waves, and let me just fix that word maybe. Waves. We are going to have, or we did two main types of wave here in grade 10. Those were the transverse wave and we did the longitudinal. Those are the main two waves we done in grade 10. When is a wave to be transverse? Well, a wave is transverse when the particles move perpendicular. I'm going to write perpendicular with that symbol to the motion of the wave. All right, that is when a wave is transverse. So let's have a look to a drawing of a transverse wave. For instance, we have, let's make dotted line here, and then we have such a pattern, which is a sine or cosine drawing. This one is a pattern of a wave. This one is a transverse wave, as we just say there. Transverse. Now, why transverse? Well, the particles in the wave, let's say this is made of particles, guys. There is a lot of particles. I'm obvious not going to draw as many, only so on. These particles are moving up at certain points in the graph and then down at other points or on the wave. So those are motion of particles. But the wave is moving in another direction. For instance, we can say this moving towards the right. So this is motion of wave. You can see that the wave is moving to the right, but the particles are moving up and down. This is what we call transverse wave. That is just recording. Now, what else is important in terms of transverse wave? The higher points on the wave are going to be called crest. It's going to be just now, but this one here, these high points here are going to be called crest. All right, and the lowest points here below are going to call trough. Well, so those are important points to remember about transverse wave. Now, in terms of longitudinal wave, and I'm going to use another color, guys. This color here is fine. I want to differentiate. Now, in this case, the particles of the wave, let's just write, particles move parallel to the propagation of the wave. All right, now in this case, we have the example of sound. Sound is an example of longitudinal wave, and you do it equation on its own in terms of sound. Now, when you represent longitudinal wave, for instance, sound, and people attempt to ask me that on how do you draw the sound wave? Well, in this case, we just use, for example, lines to represent the longitudinal wave, in which now in this case, you have regions in which the lines are close to each other, and you have regions in which the lines are far from each other. All right, in this case, they are called compressions and rarefaction. I'm not going to write this one here because this question is not about that one right now. Now, in this question, what you need to know, for example, that the particles move front and back. This is motion of particles. And then the wave could be moving to the right or either to the left. It does not really matter. It's moving there. Motion of wave. So I think with this one, we get a clarity on this specific topic. I'm going to focus on the transverse because this question is about a transverse wave. So guys, I just answered question 2.1, define transverse wave. It's a wave where the particles move perpendicular to the propagation of the wave or motion to the wave. 2.2, name the following 2 points that are in phase. Now, what are points in phase? Those points are points that have the same motion at the same time. Let me just fix those words, guys. The same time, same motion at the same time. And they are divided by distance of wavelengths. So it's one complete wavelength. That note is also there. I'm going to leave a link about the video I make on transverse wave a little bit long ago. All right, so if we point here, now points in phase are those points that can be, or they have the same motion at the same time, that first of all, and second, they are divided by a wavelength or one wavelength. For example, if you have a point here, the minimum of the closer point that is going to be in phase to that one, you measure one wavelength. So from that point to this one, for example, there is going to be one wavelength. Those points are in phase. So it cannot be 2 points in phase where the distance is less than a wavelength. So please know that one and have it in mind. For example, the next one would be at this specific space. If they are all along the same line from here to there, it's also one wavelength. So saying that, what 2 points are in phase in this specific graph? And note some points in phase, same motion at the same time. For instance, if they move both up and both down at the same time, this is out of phase, but if they do this motion, this is in phase. All right, so if we look here, we have point A and C, which are divided by 2 wavelengths. From A to C, there's one wavelength, there's the second wavelength. So points in phase in this case is A, C. Those 2 points are in phase. They have the same motion at the same time. Also something important, this dotted line is called position of rest. Position of rest. Point B and point D. Point B, we already spoke about that one before. I'm just going to rewrite it. This is a trough. This is a trough. And point D is a crest. We already spoke about that one in the previous image there where I explained all that part. Determine the amplitude of the wave. Now, amplitude is the maximum displacement. Let's maybe write a note here. Is the maximum from rest. And I'm going to write the rest with P. From rest is the maximum displacement a particle reaches from rest, guys. That is the definition of amplitude. All right, if we go to the graph, the amplitude therefore is going to be the distance from, and let me get this color, from rest to a crest. In other words, this one here is what we call amplitude, or from the rest position to the trough. Either one. That is amplitude. That is an amplitude. Let me just highlight it because it looks like it's going to, oh my goodness. Let's get another color, guys, because it's going to be looking the same. That is the amplitude of the one below. So in this question, they are giving you from crest to trough, as you can see at this specific point, guys. They give you this distance, but that is not the amplitude. That is the amplitude times 2. And they ask you the amplitude also in meters. So in this case, we have that the amplitude is equal to, and you go there, is 20 centimeters. It's going to be therefore 10 centimeters. That is the amplitude, but they want it in meters. How do you convert? You divide by 100, because 1 meter have 100 centimeters. All right, so this one is equal to 0.1 meters. That is the answer for the question. It's quite simple. Wavelength. Now, wavelength is the distance between two consecutive points that are in phase. We already spoke about that one. Wavelength is the distance between two consecutive points that are in phase. Guys, it is the length of one wave. If we go here, they gave us 4 meters from A to C. From A to C, there are 2 waves. So what will be the length of one will be 2 meters. So wavelength here is going to be, and maybe I'm just going to write it just for control, it's going to be 4 divided by 2, which is equal to 2 meters. It's the distance between any 2 consecutive points that are in phase. In this case, A and C are in phase, but there are actually 2 points in phase. All right, calculate the period of the wave. Quite simple. It's extremely simple to calculate the period in this specific question. Let's write it here, 2.4.1. What data do we have? Well, we have the frequency, which is given to us at the beginning of the question, is 1.5 hertz, equal to 1.5 hertz. You're looking for period. You have the wavelength, but we don't need it right now. The amplitude is not needed for doing any calculation at the moment. So period is equal to 1 divided by frequency. In other words, period is equal to 1 divided by 1.5. Period is equal to, when you do those easy calculations, I just want to make sure it's 0.67 seconds. Now, important, let me just write a note here. Period is time for one wave. One is with N, guys. One wave. Period is the time for one completely wave. Frequency is the number of waves that pass a point in 1 second. That's right, in 1 second. I hope you understand. I'm going, as I said, I'm explaining, but I go a little bit more to some important concept that you may struggle with. And then to finish the question, they say calculate the speed of the wave. So to calculate the speed of the wave, question 2.4.1, data, we have the frequency, which is 1.5 hertz. We have the period, which we calculate, and it's 0.67 seconds. We have the wavelength, which is 2 meters. We're looking for speed. All right, so if we do that now here, and those are the nodes I just explained there, we have a formula, which is quite simple. I'm going to move it up here. Speed is equal to wavelength multiplied by frequency. Straightforward. That formula is given to you in the exam. So here, speed is equal to 2 multiplied by the frequency, which is 1.5, and therefore the speed is equal to 3 meters per second. Guys, this is the end of the question. I hope it helped. If it helped, thumb up. Don't forget to subscribe for the channel. As usual, I went a little bit more, a little bit longer, because I'm trying to explain concepts that you might forget along the line. Thank you once more for watching. Thumb up to support the channel, and I'll see you next time. Mr. G here.